Hello, everyone. My name is Donji, and I'm your host today. This is the Metabob Podcast, a podcast where we talk to the greatest minds in AI. And today, we are super lucky to have Nisha Talagala. She is the CEO and co-founder of Pixeta AI and AI Club. And it's really great to have you here today.
Thank you. Happy to be here.
Uh, so, um, I was just wondering, what was your background? And let's just get into it. How'd you get into tech? What's your background? And yeah.
Sure. I was born in Sri Lanka in Asia. I grew up, there until I was, and then I moved to Africa when I was about 7 years old. And basically, I lived in a very remote area of Africa where there were no schools. So fundamentally, the only two subjects I practically studied when I was young were math and English. So I've always had a real fondness for math. And so that naturally drove me into kind of the tech field. And that's what caused me to study computer science. And then I got my PhD in computer science from UC Berkeley, focusing initially on distributed software. I've always been a fan of artificial intelligence. I watched a TV show when I was very young called, I think it was called Small Wonder, where there was a little girl who was a robot, and I kind of wanted to build one. But I worked in distributed software for many years. And then about 7 years ago, I decided to follow my AI passion and founded my first AI startup, which was acquired by Data Robot a couple of years ago. And then this is my second AI startup. And I've been in the AI space ever since.
That's awesome. That's pretty cool. I'm going to ask you more about your time in Africa, but first I want to know, could you just give me a brief overview about AI Club and Pixeta? From what you told me, it's a learning program for kids to K through 12 to learn about AI. And yeah, I was just wondering if you could give me some more details about that one.
Sure. So we're kind of, approaching in artificial intelligence. We're sort of approaching a tipping point, or we're already there, where this technology is sort of permeating the daily lives of all humans. Sometimes we think of AI, artificial intelligence as something that only a computer scientist or a data scientist knows, and they've got a PhD and no one else understands what they're saying. But realistically, these days, like my daughter, for example, she knows that she can speak to a digital assistant, right? She's interacted with a self-driving car and so forth. And so, these technologies are basically permeating our lives. They have interactions with our privacy, sometimes that we're not aware of, things like that. And so effectively, AI Club sort of recognizes that AI literacy, we believe, is a core skill for the future. And so we're advocating AI literacy, as well as we have AI literacy programs. We're an edtech startup, basically, an edtech startup that has curriculums, programs, and tools for AI literacy. And our primary focus is K through 12.
And so will these students actually build an AI?
Every student builds an AI in the first 30 minutes of their class, no matter how old they are.
That's awesome.
That has been true for first graders as well.
Wow. And what are these AIs? What kinds of functionalities do they have? What ranges of functionality?
So typically our canonical first AI is a sentiment detector, where you can provide sentences describing yourself and it will detect your mood. And then you can train it, different moods like happy, sad, angry, disgusted, irritated, sleepy, whatever you like. Something a kid can relate to, and they can also kind of understand that the problem is inherently complex, because it is not possible to, do a word by word detection of that. You have to understand language. It also helps them appreciate that digital assistants have to understand language and things like that, and the difficulties involved in simply understanding a sentence spoken by a human. That's one place where we start. We also, and then they go very varied. So not only do the students, always build an AI in the first 30 minutes, every student in every program we do builds a custom project, something that is entirely their own, where the data set, the training, and everything is completely their choice. So our youngest students, for example, will build an AI that knows everything they can think of about a particular animal or a particular planetary body, where they gather up the information themselves. Older high school students and middle school students tackle real world problems. Like, they use data sets from places like Kaggle, so I have one right now that is doing, medical detection from CT scans. We've had kids do diabetic retinopathy. We have, people who are doing drug discovery, work. And so ultimately, what we teach them is the end-to-end approach, but also dealing with not just simple data sets, but also complex data sets. And so they build, they can get real data from the same places that developers get the real data. So
would you say that there's a problem where people assume that AI is way too complex for everyday people to learn?
there is definitely that. And so part of it is because there is sort of a lack of resources that bridge the gap between depth and sort of without too much complexity. So either you have these news articles, where someone is saying that AI accomplished something, unbelievable, or that it's going to take over your job. On the other hand, if you try to learn about it, very quickly in chapter 1, you end up with math. And that's where most people get stuck, is that they're really looking for something in between. They don't want the fluff, they don't want the frightening or, sci-fi treatment. At the same time, they're really not looking to learn the math. And so what we've done is we've basically kind of crafted a program where we call it the 4 C's, where it's like concepts, context, creativity, and capability. Concepts is like everyone should be able to appreciate that AIs need to learn, that there's a relationship between learning and data, and the quality of data results in the quality of learning. There are ways to measure, right? Ways of improvement, what an algorithm is, and so forth. Those are concepts. You should be able to understand context, as in if I'm walking in my daily life, I should be able to identify where AI has been interacting with me. Like if I were to go to a website and buy a product and I get recommended stuff, I should have a rough idea of how that happened. And so forth. And then one thing we have noticed that even adults have told us is that even if they didn't come in thinking they wanted to build one, the mere action of building one and querying it and appreciating what it can and cannot do gives them a really good insight into the limitations of the technology. So it's just something as simple as you ask it a question and it gives you a ridiculous answer, and then you go examine the data set and you realize it simply does not know what you're talking about, because what you're talking about was never in the data to begin with. So somehow through that combination, what we found is that kids particularly, and this has also been true for professional adults, they are able to capture the essence of it. And from a math standpoint, I can tell you that our elementary programs obviously have no math. Middle school programs, we expect them to understand averages. Basically, if they can understand a square root, that's awesome. High school programs, we expect them to know, those things and be able to appreciate what a histogram is and stuff like that. And that's about it. And so we craft the concepts to match the level of math and the level of coding that is realistic in the age group.
So I was reading up that you hold 73 patents and you have a PhD. And I was just wondering, that sounds extremely technical. And so I'm just curious about, how did you go from
that to this?
Yeah. Well, also, did your upbringing in Africa kind of lead you to this path of pursuing the educational route as well?
Well, my parents are teachers. Okay. So I've always been sort of oriented. My mom is a physics teacher. My dad is a math teacher. And that's actually what they were doing in Africa. They were teaching. And so I've always kind of had that notion, but I think in the end, that's actually not what brought me to this topic. What brought me to this topic is I have a daughter. And, she's 12 now. And about 3 years ago, I really wanted to teach her AI. And I could not find a tool that would help, that would make sense to her. And I searched and searched, and finally I glued some things together that did the job, and we were able to build the first AI, and she liked it. And then very quickly she's like, okay, I need to teach it some more stuff. And she had no patience whatsoever to find a data set. So I ended up becoming her data engineer for practical purposes, looking for data that would be comprehensible to her and at the same time, easy to build. And the situation was just crazy, and it didn't work. And about 6 months later, we gave up and stuff like that. And so that, I think, is where the idea really kind of seeded in my head, is that, these kids can get it, they can do interesting things, but the environment isn't there for them. So when we first built our product to make AI easier to use, she was one of the first people who tried it.
Oh, that's really interesting. So if we could backtrack to your background in distributed software systems and applications, it just seems like you did so many things reading your bio. It's really impressive. Non-volatile memory file systems. What of those things in your past projects were you really proud of like what you've created, because you've had 73 patents. That's a lot.
So no, I mean, so I've really I've really always liked sort of technology development. And one of the things that I think, so if you're kind of, if you come out of, with a PhD, you have a couple of different sort of venues that you can go. One of them is obviously to become a professor. The other is to become a researcher in a research laboratory. The other third is to go into corporate, to industry and just and become an engineer or and one of the things is that I always wanted to build real products. On the other hand, I'm also I'm interested in technically deep things, and so I didn't really want to become like a member of a product organization where I'm just building product day after day. But I also did not want to be in a researcher where I might be able to publish papers day after day, but I could I'm never it's very rare to see what you build see the light of day. So the compromise, initially I joined an advanced technology group, then I built an advanced technology group where I did all of this. But then I found that the startup world is the place I can find the balance I want, because startup worlds demand that you solve real problems. Frequently, if you're in a space like AI that's innovative, it has to be frequently an innovative solution. There's just no choice in the matter. But at the same time, it's not an innovative solution for the purpose of innovation. It's for the purpose of solving a problem. So I would say that over the years, I mean, I've done a whole bunch of different things, but to be honest, the thing I'm most proud of is the teams that I've built. There's sort of nothing as cool as an awesome team. A group of people who just, the thing they create, you can just look at it and that no one of them could have created it.
And what was your first experience building one of these teams?
So my first experience in leading a team was actually my first job, Sun Microsystems, a company that went out of business a long time ago. And I was basically, I was an engineer. I had been working there for about 3 years, and I was asked to lead a team to propose a strategy for data integrity for one of our products. And yeah, that was my first experience. And I think what I really learned from it is just how different people's perspectives can kind of come together in a robust solution. And that, I think, kind of made my day.
What were you building there?
So I was actually working in the storage systems area. So I was mostly building, technologies like file systems, how to make Sun's products faster for databases, things like that. And this particular project that I worked on was for data integrity. So one of the things that you can kind of imagine is that if data gets corrupted silently, it can lead to a lot of bugs down the road and stuff like that. And so there are mechanisms in place to make sure that that doesn't happen. And this was one of them.
And then you also worked at Intel?
Yes.
What was that like?
It was a really interesting experience. So I'm a software person. However, I have worked in my share of hardware companies. And being a software person in a hardware company is a very interesting experience. I think the one thing that I think I really learned from Intel was what scale looks like. Companies like that operate at a level of scale that it's just hard to kind of mentally comprehend, particularly for someone who's startup oriented like me. So, one thing, for example, I was the technical lead for a team of 200 people. There were, and I was just initially, it took me a very long time to wrap my brain around the fact that there are people in my team that I don't know the names of.
Oh, wow.
And because I'm used to a little startup where there's 10 of you and you all not only know who's doing what, you're in each other's lives, your families, you name it, we're all over the place. But, companies like that, they operate at such a massive scale that you really have to think very differently. A single $1 million doesn't matter in a company like that. If you're having a conversation about $1 million, you're wasting your time.
Oh, wow.
Conversations are had about hundreds of millions of dollars or billions of dollars. That's what you want to talk about. And so I think that was the one thing I felt like I took away from that. It took me a while to get used to it, but I kind of went like, wow, it's a very different animal when you're talking about numbers that big. So.
And you were in a startup before that?
I was in a 10-person company before that.
Was that Gear 6?
Yeah, I was Gear 6.
What did you guys work at there?
So we built distributed caches. So we basically built these big clustered memory systems that could make computations much faster, more in the high performance computing space. So for example, when Gear 6 was in business, a lot of the animations that were made in Hollywood were made by them using this. So for example, like B-Movie, Kung Fu Panda,
B-Movie, Kung Fu Panda,
those are all rendered.
Those are classics.
Yeah, so those, I mean, so it was really cool. And so I got to go and, hang out at the studios and, talk to the artists and stuff like that. And part of it is that they require enormous amounts of compute power in order to generate them. And so, and the faster you can do it, the more likely that the movie can be iterated, can make its release deadline and so forth. So we worked on a lot of that.
What was it like to write software for that? What were you trying to optimize?
Oh, no, mostly speed. So speed of accessing the data.
Uh-huh.
So, yeah, so it's basically, the software was written in C and C++. It was clustered software, very, very focused on low-level details like network operations and things of that nature. A distributed system, so you have all the kind of interesting distributed systems bugs that occur when you have a cluster and messages zipping back and forth and so forth. But that's really it. So it was a lot of fun. I love. I started out at low-level code, and so I love that kind of stuff. And one of my favorite things about that was there was a time that I could read TCP traffic in binary. Because we had network problems that was so gnarly that they would break all the tools, and I had no choice but to look at the bits and go, okay, there's the header over there. There's this.
Really?
Yes.
That's amazing.
I love that. And obviously now nobody does that anymore. And so I'm dating myself, but I thought that was the coolest thing ever. You won't find a single student out there now that thinks that's a good use of time.
Wow. So you spent your entire career just building really low level and extremely performant products.
At the beginning, yes. It was when we started, when I started working on AI is when I really, went to a higher level of software.
What company were you at where you first started working on AI?
So AI, basically, I co-founded a company called ParallelM. And ParallelM focused on production AI. So these days is actually I actually coined the term MLOps. So I wrote the first MLOps Wikipedia.
Nice.
And stuff like that. And so ParallelM defined MLOps. I believe it may still own the trademark for that, although nobody, now that everybody's using it, I don't think that's enforceable. But the idea was we kind of recognized that just like databases or just like any other kind of software, machine learning systems have to be managed, and they have to be managed in particular ways because they have problems that are unique to them. And so we realized that just like DevOps for software, there has to be an operational practice for machine learning. And so we built a platform. It was called MCenter, which was the machine learning operations platform for large enterprises. So companies that had to manage their models because they have legal implications, they have to, make sure that something is properly tested before it's rolled out, stuff like that. And so, Data Robot purchased ParallelM in the middle of 2019. And the Data Robot's MLOps product was based on the ParallelM software.
Wow. So when you built that, were you working with companies to help them improve their ML workflows?
Yes, essentially. Yeah.
Oh, nice.
So these days we call it, these days the term MLOps is actually quite well known. Back then, we were the only people writing about it. But yeah, the idea of a workflow of machine learning, the idea that you have to optimize the workflow, iterate across it, the idea of drift and ML health, that you have to measure drift, like long before COVID broke all the AIs. I think the fact that COVID broke all the AIs last year has helped more people understand what drift is.
Wait, could you expand that? What do you mean it broke all the AIs?
So if you can do a little Googling for this, and I wrote a Forbes article on this last year as well, is AIs thrive on patterns. They learn patterns, right? What happened last year? All the patterns broke. We all started doing things that we had never, ever done before, right?
Oh.
Traffic patterns broke, eating patterns, food, ordering driving patterns, purchasing patterns, you name it, it changed. And so a lot of AIs simply did not know what to do with that because the incoming data did not match anything they'd ever seen before. And so that also got a lot of people to kind of appreciate that these kinds of issues can occur for machine learning systems. And the fact that when machine learning systems are faced with data that they haven't seen before, they don't have the ability to say, well, I don't know this. What they do is give you a wrong answer. So they don't have the internal ability to recognize that they cannot answer the question. So typically you have operational programs that can detect this kind of stuff and say, well, I'm pretty sure this is an unsafe operating territory for my AI.
So like putting in an uncertainty score?
uncertainty score or detecting drift. So what's drift is fundamentally a shift between training data and prediction data, or shift between prediction data and previous prediction data. There's lots of ways to do drift. But the idea is that, when you build a machine learning model, you have defined intentionally or unintentionally an operating space for that model, a space in which that model will behave as expected. If circumstances take it out of that space, then it will not behave as expected and could behave in any number of unforeseen ways. And so there are detectors you can build. So one thing we built at ParallelM is we built maybe one of the first production drift detectors.
Oh, that's cool.
Yeah, and what was hard at the time, because people hadn't experienced the problem, right? They could appreciate that in theory that this could occur, but unless you talk to a company that has actually been in deployment for a little while, they couldn't. And so last year, I think that it was a kind of unfortunately, a wake-up call for many people, because it happened to a lot of people because of this single one thing.
So what advice do you have for startup companies looking to implement AI?
So no, it's a really good question. So the general advice that I give people is essentially kind of, it depends on, so there's a couple of different things for a startup company, right? If AI is your value prop, and what I mean is something to the effect of, your pitch goes something like, problem is important, people have been solving the problem forever, nobody has used AI, I'm going to use AI, therefore that is, why I'm going to win, then AI is central to your value prop. So for there, I think a lot of it has to do with how you're going to get the data. So you don't want to end up in a chicken and egg problem where you can't build your AI because you don't have any data, and no one will give you data because you don't have your AI. So that's called the cold start problem, and you have to find some way to break the cold start. And either maybe because you're an expert, or you convinced a customer to give you data, or whatever it is, you have to, kind of come out of that becoming on the cold start. And then I think the next one is my general feeling has always been that build the simplest thing you can and improve upon it. Because, it's amazing how robust some of the simple techniques are. And the advanced techniques can do better, but they are temperamental. So you may be better off getting a product out there, getting more data with a simple technique, and then making it fancier. And then the third one is, of course, is the hiring, because so I've actually written a couple of articles about this, because during my ParallelM days, I learned the hard way, how to hire scientists. And the thing is that if you're a startup, you cannot compete with Google. It's not just not possible. And so you have to pick your battles, because the people you want, if they get an offer from Google, you just can't fight that and win. So you have to figure out exactly what it is that you need, and have someone for whom it's a win-win. And so the way I found that is, as an example, is you can find really bright people who've done statistics who may not have enough computer science knowledge. And so if you work with them and you're willing to teach them Python, and they're in turn willing to do your data analysis, that's a win-win.
That's smart.
Right? Or, you basically have to find something like, if you cannot hire the average engineer coming out of Uber, because they have the mix of AI, practical implementation. You just can't afford that.
Right.
But you can hire someone for whom you can give them something they need.
Got it. Yeah.
And that's, I think, where I was, and the other thing that, you have to compromise somewhere. And one thing I know, really came across is the desire to code and the interest in coding is really what I prioritize, not necessarily their ability to code. So I had to fire for example, unfortunately, I had to fire a very senior data scientist because their desire to code was not there. So it wasn't so much that they couldn't code, it was that they would write poor code that would then infuriate the engineers, and they didn't want to fix it. Whereas you have someone who doesn't know how to code, but they really, really want to, that's something you can work with. So it's just, you just kind of have to, it's impossible to afford everything. So you have to figure out what you need.
So you've wrote many articles for Forbes, it sounds like.
Yeah, I write regularly. Yeah.
What were some of your favorite articles about?
So I have written articles about full stack data scientists, and how to hire data scientists. I've written about kids a lot because it's an area of passion for me, and I also write periodic articles on AI trends, and particularly on ML ops trends.
Oh, that's awesome. So then was after that, did you work on AI at any of the following companies after that?
No, so I actually started AI Club right after I left ParallelM. So I left
Okay.
just a little bit before the acquisition, and then started this company.
Nice. And then did you have to implement a lot of AI into building the tool for Pydexia or Pydexa?
Pixida.
Pixida, sorry.
No problem. So actually, oddly enough, yes. So what happens is that in order to make these processes easy to use, you actually have to put in a fair amount of automation. Now, machine learning automation is a relatively sophisticated area. Auto
Mhm.
ML products are everywhere. What is not sophisticated is feature engineering automation or data preparation
Mhm.
automation. So because that's still done a lot by hand. So we've developed a fairly sophisticated data prep automation. So the reason that our students can bring in complicated data sets from Kaggle, even if they can't code and they can build an AI with them, is that we build software that will analyze the data set, figure out what needs to be done in feature engineering, assemble a feature engineering pipeline, and either execute it for them on the cloud on anything from single node to scale out to generating code for them. So they get a Python program that says, this is, if you wanted to run this, these are all the Python functions. So it's a code generator, basically. So yeah, so
Wow.
we're doing a lot of that kind of stuff. And that's the reason why the teaching machine works along with, if you're building toys, you don't need to do that. But if you're teaching people to build real things, you need to do that.
Yeah, I was looking at your website and I was like, it looks, simple on the surface, but knowing your background, I bet there's a lot of complicated stuff going on in the background. That's pretty high tech.
So maybe one thing I could show you that might be sort of illustrative of this. So we just had an event last weekend, which was essentially our student research symposium. And you can just take a quick look at the titles of the presentations. And these are all students, grades 7 through 10. So if you look at the student presentations.
Oh, wow. Using transformers and BERT to predict disasters from Twitter feeds. That's really cool. To be or not to be, Shakespeare, taking AI back in time.
It's a play analyzer. It's a linguistic play analyzer.
Wow. Valuable trash. Forecasting Alzheimer's with AI and multimodal data. These sound like PhD papers.
Yeah, and see that these are all done by kids grades 7 through 10. And that's because of the tools that we've built that enable them. These are all real world data sets. Like the Shakespeare thing was actually Shakespeare's plays, and stuff like that. These are real tweets, real MRI scans, real pictures of trash, and so forth.
And I noticed that there's a lot of like really cool videos that they've created. Do you help them build these presentations?
So what happened was this was a live event. This was our first student research conference. It was over this weekend, and these were the presenters. So it happened to be a recorded conference. So these
cool.
Presentation. So they each gave like a 10-minute presentation on their work.
Wow. And can you just talk about one of the projects that you liked? I'm sure you liked all of them, but just for an example.
Sure. So if you look at the Alzheimer's project, right, which is the Alzheimer's with multimodal data. So it's in the middle. So the essence of this is that, Alzheimer's, even to date, is an incurable disease. But what has happened is that, doctors know that the earlier they can forecast that someone is going to get Alzheimer's, the more they can do therapeutic intervention, to kind of slow down the rate of the disease because it cannot be cured. So what this project basically highlighted is that, many AI focus on a single modality, which means they can do images, they can do text, they can do something, but they only do that one thing. But the real world is a multimodal. Like the human body is not a single modality, right?
Right.
A brain scan gives you one perspective, a clinician diagnosis or a blood test gives you another perspective. And so the question here is, can you combine multiple modalities to get a better forecasting? Now, this is and that's what was, that's what's being explored here, is the ability for multiple modalities to get you better earlier forecasting. So the three modalities were clinician notes, which are text, MRIs, as well as essentially numbers from the brain, like the size of various parts of the brain, and how that changed with time. So what makes this sort of interesting is this is a real world data set. It's called OASIS 3. OASIS 3 tracked, I think, a little over 1,000 patients over 30 years. So the data that was fed into this study was not toy data. This was serious data. And so that's what makes these studies interesting, is that they are, they're real world data. That's the same data that researchers study on.
And then what kind of findings did they make in their research?
So the research in this particular case, the research found that if you combine the modalities in a kind of like a voting mechanism, that you can actually dramatically reduce the number of false negatives. So false negatives is the case where we think the person is not going to get sick, but they do, and that's the most dangerous one, because that's the person who's not going to get treated.
Ah, I see. So it's focusing on the highest impact area. So you don't have to necessarily say yes or no, this person's getting Alzheimer's, but if you can solve those false negatives, you can still make a huge impact.
Exactly. So that's the kind of stuff where, because ultimately at the end of the day, say that you got treated and you were never going to get sick. Okay, so a little bit wasteful, but still okay. But if you did not get treated and you got sick, that's not okay.
Interesting.
So so it showed that you can really dramatically reduce the false negatives if you use a multimodal approach.
And do these kids get like really into it?
They get really into it. I mean, these are all their projects. You can watch the videos, and but yeah, they get into it. These are.
We'll add some of the links to the videos of the student projects in the link in the description.
Absolutely, yeah. I think it would be wonderful, because I think for me, it's just really, it kind of shows, first of all, if you look at them, they're all different topics, right? That's thing you can notice, is that they're all different topics, which kind of shows you the breadth of AI. The other is that each of the topics is passionate for that student. This is something they care about, and so forth. And that, I think, is one of the things. So it's something I noticed sort of in my personal experience with my daughter as well, is when I was working on that low-level software, I found it impossible to explain to her why she should care about what I did.
Yeah.
And at one point she was like trying really hard, and then she told me, when I search for something on Google, does what you do have any impact on the other? And I'm like, okay, I'm so needing to go get a job at Google now, because she clearly doesn't think I add any value to anyone.
Oh no.
Right? And whereas now, basically,
you're like, did you see the Bee movie? Come on.
Yeah. So it's just so. But the thing is that that's one thing I've realized, is that these one of the things that makes the AI intersection with middle school and high school so impressive is that they have a way to express something they care about. In a way that they can see the result of. And that motivates them.
And something that their parents couldn't do.
Yes, and something that their parents couldn't do. Right? And so I think that thing that's bringing that technology directly into their hands, and they know that if they train it one more time, it might get better. Suddenly the tie-in is very direct. And as much as I love computer science can be a bit of an abstract topic. And so unless you're truly passionate and you can get like worked up about recursion and lists and the finer points of debugging and pointers, I do, but at the same time, I can totally get if somebody else doesn't. This is something that they can connect to, and they can find a way to connect.
I remember my mom signed me up for this like art class when I was young, and we did pastels. Yeah. And then it really stuck with me. And then that kind of led down the path of me wanting to do art, then graphic design. I could totally see how when you expose kids to these things, it's like most people don't think it's possible. But then now that they know it's possible, they grow up through high school and college, knowing in the back of their head that like, oh, AI is a possible route for me, so maybe they think about taking certain paths that they might have not before, because they just thought, oh, I can't figure that out.
Exactly. And that's, I think, one of the things is that, I think if you can expose it to them before they decide it's not possible. Because one thing I've noticed in dealing with kids is that they're fearless when they're young. And then we were all fearless when we were young. And somewhere along the way, we learned to be afraid. You can expose them to stuff before they learn to be afraid, then their imagination is what drives them, not their fear. So that's
a quote if I've ever heard one. Did your daughter take the course now?
Oh, she's taken a bunch of our courses. Yeah.
And
Yeah.
she's liking it?
Oh, no, she loves it. So she did the Alzheimer's project. That is her. So if you watch
Oh,
her,
wow, that's awesome.
that's her, and then the other kids are, and also kids who, all of these kids have taken our courses. So, yeah, so she did this for her science fair.
That's awesome. And so where are you looking to take this company, and what are you looking to do with it?
So fundamentally, I believe that AI literacy is something that every individual in the world is going to need to have. And if you have a minute, I'm going to go into my car analogy. So the car analogy was essentially that when cars were initially, created, the driver needed to know the right fuel and air mixture for the engine. They needed to know exactly how to control how the spark plugs met the engine fuel. So, but these days we don't know any of those things, but most of us have either driven in a car or been in a car. So AI is like that. It's going to be in your life, whether you like it or not. And a basic level of literacy is required. Like we have general basic literacy of how to not get killed by a car. Whether we're driving it or not stepping in front of it, or understanding what we can expect and so forth. So I want AI Club to become the AI literacy company. So essentially that we bring AI literacy to anyone in the world who wants it. And we're starting with K-12. We've had thousands and thousands of kids take our programs. These are some of them. We've shared it with adults. We've shared it with hundreds of educators and so forth. So that's what we're doing, is bringing this.
And are you looking to, is this a program outside of school, like hours, or is it something that you're also planning on integrating into school programs?
It's already been integrated into several private school programs. And so it's been taught to private school, high school students. We also offer it out of school as well. And we offer curriculums and curriculum licenses for teachers. So we have teachers in the United States who are teaching this program. Themselves.
Oh, wow, that's awesome.
Yeah.
And then who else is building this company with you? It says that you're co-founder of this. I was just wondering, how did you meet your co-founders?
Oh, no, absolutely. So my co-founders are Sindhu Ganta and Swami Sundararaman. Swami and I have worked together since our days at Fusion.io when we did some of the non-volatile memory and things like that. We were all together at my previous AI company, ParallelM. So we've worked together a while. So Swami is an expert in distributed systems. That's actually how we met, is we have a shared technical history in that front. And Sindhu is an expert in AI.
Oh, wow.
So that's kind of how we put together, and we're all parents.
Oh, so all of your kids have taken the course.
Their kids are very young. Swami's kid is like 1.5 years, and Sindhu's kid is like 4 years old. So Sindhu's kid has learned some AI with us, yes. So
wow,
yes.
That's really cool.
Yeah. So anyway, so that's kind of how we came together. We're all technical people, but we all have sort of a shared interest in making this stuff easier to use. So if you want to know more about them, we actually have a section here which has all of their pictures and bios.
Yeah, if you send that to me, I will add that into the show's link in description.
So here we go. So I'm just putting that here. So if you go to this page, you will see the core team, and the co-founders are Swami and Sindhu.
And what is there anything else that you wanted to talk about your company, or anything that we didn't cover so far?
I think the only thing I would actually say is that I think we're in a really interesting time in AI, and I mean interesting in a very positive way, not in may you live in interesting times kind of thing. But I think we're really in a space where a lot of people talk about sort of like this AI sort of singularity and this fear that AI is going to take over the world. I think the more likely reality is that it's going to be all around us, and to the point that everything we do has an AI assistant of some kind engaged in it. And that's what I call the tipping point. So I think this immersion point is already here. And now, if you look at massive models like the Google recent trillion, parameter model, it is certainly possible that you will create AIs that can take over large swaths of human function. So I wouldn't dismiss the other fear, but I do think that there's maybe a more practical concern before we worry about the AI that's going to, become the Skynet, as in Terminator or anything like that.
And by practical concern, what are you talking about specifically?
No, it's simply like, do we really appreciate how much information is being gathered by us? by how many different kinds of people. How many devices do we interact with that are making recommendations about us, predictions about us, right? Do we even know who they're being made to? You know, I mean, a simple question of if I go into an online store and I decide to buy a pain medication, am I absolutely convinced that that is not being reported to my insurance company? I'm absolutely sure that my insurance rate isn't somehow tied to that.
Or what are the algorithms for YouTube and Facebook and social media showing our kids for, you know, it is kind of concerning that, you know, one kid could be shown certain types of content that lead them in a different direction in life, and then than other kids. It's kind of like these are AI teachers on YouTube.
Exactly, right? So you can imagine, like, there's a lot of sort of stuff like that kind of going around, right? Information, like, what is the information I'm seeing? How was it selected to be put in front of me? I don't have the cycles to browse Facebook all day looking for things that it doesn't want to show me, right? If I have 5 minutes, I'm going to see what they chose to show me. And how did they figure out that was the piece of information I should see today? You can see kind of like all sorts of, you know, it's a very strange and complicated world that we're entering into. So I do think that I think is a much more imminent issue than, you know, some AI that could be built in the future that could do everything a human does. I think we've got much bigger problems than that. So that's, I think, what I would leave it. And that's part of the reason why I think literacy is so important, is just the base ability to navigate that is, I think, just a core skill these days.
And that's actually one of the last topics I do want to touch on is this literacy concept. So literacy as in, like, you know, a student does this mean that, like, you're saying you want to introduce students to the terms of AI and like what words are being used? So if they were to do more research, maybe they could like start learning on their own?
No, I think of literacy in a very practical way, which is, do I understand enough about the technology that I can navigate my daily life in a way that, you know, I am understanding what I'm dealing with? So if I go back to the car example, like, do I understand the rules of the road? Do I know how to get a driver's license if I need one, right? Do I know that I'm not allowed to drive a car without a driver's license, right? And things like that. Do I have enough understanding of how a car operates that I can tell that I need to call AAA, right? Doesn't mean I have to be able to be a designer of an engine, but I do need to be able to, you know, function in a world that has a lot of cars in it. So for me, AI literacy is things like, do I understand sort of the role of my information in things like recommendation systems? If I interact with a digital assistant, if I want to take steps to protect my privacy, do I understand where I might be able to take those steps? If I wish to pursue a career in AI, do I know what I might want to do next? If I am a doctor and I wish to, you know, understand the role of AI in my field, can I do that? If I am going to buy a product, you know, do I know what questions to ask? So like I'm doing, you know, I did a seminar with some partners recently just for, you know, school administrators, which is because there's a lot of AI these days being used to recommend learning outcomes for students. And the focus of that seminar was, do you even know what questions you should ask to figure out whether or not this AI was built in an unbiased manner?
Interesting.
Like simple questions like, you know, you can ask simple questions like, okay, how did you train your AI? What kind of demographics data did you use? How did you convince yourself it wasn't biased against minority populations? This is, you know, just basic stuff like purchasing. How do I purchase a product that has AI in it, you know, and make sure that my students are protected? So that's what I mean by literacy. It's day-to-day functioning in a world full of this technology. That's, I
mean, really, these students are going to grow up to be future stakeholders and companies who have to make these decisions. And yeah, I think it would be great if they were able to make smart decisions about that could prevent things like massive, you know, discrimination by AI or something like that.
Exactly. So it's really, you know, kind of helping them appreciate what are the unsolved questions, what are the basics, what are the limitations, so that they don't see it as magic. They also don't see it as something to be deathly afraid of. But they do understand that they have a role to play.
I see.
In creating it.
Wow, that's I never thought about AI education like that, but that's a really inspiring point of view.
Yeah. No. Very welcome.
Thank you so much, Nisha, for being on our show. This was a really great interview. And for people who want to find out about your product, they can go to aiclub.world aiclub.world, WORLD. Is there anything else that you wanted to cover?
No, I think we're good. And if anybody is, interested, we also offer a lot of resources to nonprofits and such. And so if anybody's interested in chatting with us, yeah, just go ahead and, go to our website, or you can always publish, I'm going to give you guys our info email. So anyone can drop us a note there anytime they like, if they have any questions or would like to work with us on anything.
That's great. That's great. Yeah, thank you so much for being on our show. And I'll put the links in the descriptions. And yeah, thank you for being on the show.